Look at Saturn's rings and they feel permanent, like something that's been spinning there since the solar system first pulled itself together 4.5 billion years ago, a fixed feature of the planet as old as the planet itself. Here's the part that doesn't sit right once you actually check it. The rings are probably younger than the dinosaurs. Not older, younger, and they might not even last long enough for whatever comes after us to see them. That claim would have sounded absurd for most of the last century. Saturn itself formed early, in the first few million years of the solar system, condensing out of the same disk of gas and dust that built every planet here. The obvious assumption was that its signature rings formed right alongside it. Frozen debris left over from the same process, just another leftover from the planet's birth. Nobody had a precise way to test that assumption because you can't weigh a ring system from Earth, no matter how good your telescope is. In 2017, NASA's Cassini spacecraft got the closest look anyone ever will. After 13 years orbiting Saturn, running low on fuel, the mission team committed to one final maneuver. During its final orbits, called the Grand Finale, Cassini threaded the narrow gap between Saturn's cloud tops and the inner edge of the rings, over and over, 22 times, before deliberately diving into the planet's atmosphere to burn up and avoid ever contaminating its potentially habitable moons. On those last passes, the ring's gravity tugged on the spacecraft's trajectory just enough to measure. Led by Luciano Iess, that gravity data gave scientists the first precise mass for Saturn's ring system. Published in Science in 2019, about 1.54 times 10 to the 19 kilograms, roughly 40% the mass of Saturn's small moon Mimas. That number is small, especially set against how visually massive the rings look from any telescope, stretching wider than the distance between Earth and the Moon. Suspiciously small for something supposedly as old as the planet itself. Here's why mass translates to age. Saturn's rings are almost pure water ice, well over 90%. Brilliant and reflective under sunlight. Space is not clean. Dust and rocky debris rain into every ring system constantly, darkening and polluting the ice grain by grain over time, the same way a white snowbank left by the road turns grey within days. A ring system that had been sitting there for 4 billion years should look dirtier and weigh more than this. The pristine ice and the low mass both point the same direction, young. A companion study led by Matthew Tiscareno, using close-range remote sensing from those same final orbits, backed up the picture from a different angle, tracking how the ring particles themselves reflect and scatter light. Estimates converged on something startling. The rings are likely only 10 to 100 million years old. Dinosaurs were already extinct by the low end of that range. At the high end, some species of dinosaur might have looked up at a Saturn with no rings at all, a completely bare gas giant hanging in a Cretaceous sky. That raises an obvious problem. If the rings are that young, what actually made them, this recently, out of almost pure ice? One serious answer predates the Cassini mass measurement. In 2010, Canup proposed that a Titan-sized moon migrated inward toward a young Saturn and got torn apart by tidal forces, its icy outer layers stripped away into a ring, while its rocky core fell into the planet. It elegantly explains the near-pure ice. The problem: Canup's version placed this billions of years in the past. Other researchers, including Ryuki Hyodo's team in 2017, proposed something similar in spirit but different in the details, pointing not at one of Saturn's own moons, but at a passing Kuiper Belt object. Torn apart by tidal forces during the late heavy bombardment, a chaotic stretch roughly 3.8 billion years ago, when the outer solar system was still getting pelted by leftover debris. Both ideas explain the icy composition well. Neither one, as originally framed, explains rings that are only tens of millions of years old. So the Cassini mass data didn't just answer a question, it broke the leading explanations, forcing researchers to ask whether a shredding event of a moon or a captured object could have happened far more recently than anyone had modeled. Not every scientist accepts the young ring's conclusion at all. Aurelien Crida has argued the debate isn't settled, pointing out that the measured mass is also consistent with a ring system that started out far more massive billions of years ago, close to Saturn's own birth, and has simply been eroding down to its current size ever since, through the same slow loss processes still running today. Same data, two defensible stories about the past, and no independent measurement yet that cleanly rules either one out. While one side argues about how the rings began, there's separate, harder evidence about how they're ending, and it comes from a completely different discovery, made independently of the age debate entirely. Electrically charged particles of ice, stripped from the rings by sunlight and Saturn's own magnetic environment, are getting funneled along Saturn's magnetic field lines straight down into its upper atmosphere, concentrated at specific latitudes rather than falling evenly. James O'Donoghue's team caught this directly in 2018 using infrared observations from the Keck telescope in Hawaii to detect the glow where that falling ice reacts with Saturn's ionosphere. The phenomenon has a name now: ring rain. The scale is startling once you convert it into something you can picture. O'Donoghue's measurements suggest ring rain alone drains enough water ice to fill an Olympic swimming pool from the rings roughly every 30 minutes, day and night, continuously siphoned straight out of the ring plane and down into the planet's clouds. Left running at that rate by itself, the entire ring system empties out in about 292 million years. Add in a second, separate loss process Cassini measured directly during those same final orbits, material falling inward near Saturn's equator, and the honest estimate drops further, under 100 million years before the rings are simply gone. Both of those numbers carry a real caveat worth saying out loud, the same kind of honesty that matters everywhere in this story. They assume the current rate of loss holds steady into the future, and there's no guarantee it will. Ring rain could speed up as the rings thin out, slow down, or behave unevenly as the system changes in ways nobody has directly observed yet. Treat under 100 million years as an honest estimate built from the best data available, not a countdown clock with a fixed date on it. Put the two findings together and something strange falls out. On cosmic timescales, a ring system that might be only tens of millions of years old is also on pace to vanish within the next 100 million or so. Rings that look permanent from any single human lifetime or any single human civilization are on the scale the solar system actually runs on, closer to a temporary event than a permanent feature, a brief flare of geometry around an otherwise unremarkable gas giant. So the version of Saturn you're picturing right now, with that unmistakable ring around it, may be a coincidence of timing more than a fact about the planet. Every photo, every textbook diagram, every model of the solar system you built as a kid assumed those rings were simply part of what Saturn is. 4.5 billion years from Saturn's birth, for a window that might only last a few 100 million years out of that entire span, something happened, or is still happening, to wrap ice around a gas giant. You exist inside that window, able to look up and see it.